Thank you very much. My name is Josh. I'm going to pre-warn you that this presentation is going to be littered with photos of my dog. That is one photo of my dog. That's him sunbaking. Felt topical to today's weather. So as mentioned, my name's Josh. I am a senior software engineer at Condé Nast International. A bit about me here and some social links. I'm Australian. I cycle, take photos, and I love my dog. Need I say more? So if you don't know who Condé Nast is, we publish all of these magazines. We have 30 wholly owned, or 30 markets, 11 of those wholly owned. So we publish both print and digital publications across the world, over 65 websites. So on with it then. So what is Kind? Kind is Kubernetes in Docker. It's pretty much what it says on the tin. It is a tool for running local Kubernetes clusters with Docker containers as nodes. It's effectively using Docker in Docker technology to what you would normally consider a Kubernetes node is instead a Docker container running on your local machine. So we'll take a quick look at the architecture. So as you can see, as I said, it's running in your host machine. The node container is then running a bunch of other containers within it. All of the services and pods that you spin up are running within that container. So why do you want to use Kind? It is rapid startup. It takes about 30 seconds to get a full cluster going. Supports multi-node HA clusters. Supports the Docker runtime on Windows, Mac, and Linux. It's a CNCF certified conformant installer. And under the hood, it actually uses kubeadm. So it exposes the full kubeadmin config surface. I'm going to be switching between kubeadm and kubeadmin because I don't know which one's meant to be correct. And that is my dog staring at a camera with his nose. So how do you install it? The easiest way is if you have Go installed on your machine, just go get and then the version, make sure you're utilizing Go modules so you can specify which exact version you want. You can build reproducibly with Docker on your local machine, just clone and then make build. It'll utilize the local Docker instance, pull all dependencies, which I don't think there are many, and we'll build the binary for you. There's also pre-built binaries available on GitHub. So how do you create a cluster? Literally create cluster. And I can actually just demonstrate that real quick. Now, when I say it takes 30 seconds, like I'm not kidding, this will be done quite quickly. It will automatically set your kubeconfig variable so that you can start talking to the local cluster immediately once it's finished spinning up. What are we at? About 20 seconds. Don't make a liar of me. And there we go, it's done. So we can, normally it would do that automatically, but apparently not. And so now we can and there you go. We now have a local Kubernetes cluster running on Docker. I can Docker PS if I spell it correctly. And that's the cluster right there. So what else can you do? You can configure it to use a certain version of Docker. If you go to hub.docker.com/kinda/node, you'll see that there's a bunch of various tags there. It will pull down the one that you specify and will utilize that as the cluster version. You can spin up additional clusters by specifying a name flag. So you can have multiple of these clusters running at any one time. There is a config file that you can use, and we'll go a bit over that as we continue into the presentation. You can kind get kubeconfig will actually spit the entire config out directly to your terminal, or you can use get config path to specify and export that into your kubeconfig variable. And you can also sideload Docker images and archives. So if you, by default, kind will uses the if not present configuration for Docker images. So if, as long as you don't specify the tag as latest, pod image that is, or a container image that is specified with the latest tag will always pull from the remote repository. If you specify a version tag and you've already sideloaded that image or archive into the cluster, it will utilize the local version that's already been added. Configuration. So kind has its own configuration API, which you can use to set some parameters when you're booting up a cluster. You can specify the number of nodes, any port mappings, and some additional networking stuff. And as I said, it's also using kube ADM under the hood, so you can specify config patches for kube admin. I told you I was going to flip between those. So here's some example configs. We're not talking about very, very difficult configs, and we are still in the alpha of kind, so they're still adding additional configs consistently. In this particular case, we can spin up a six node, and by nodes, it's spinning up 6 Docker containers on your local machine. 3 of those will be the control plane, 3 of those will be workers. The additional port mappings, one of the caveats of kind is that, similar to a few of the other local cluster installers, is that you need to specify node ports in order to allow traffic into your services. In addition to that, kind requires you to configure additional port mappings to the container port and host port. The host port is the port that you want to connect on localhost into the cluster. So host port is effectively the exposed port on the Docker container or the node that it's running on. And this is an example of a kube admin patch. So in this case, we are changing the service subnet. The kube admin configuration surface is massive, so I'm not going to go through a whole bunch of examples for that. Obviously, all the documentation is available online for that project. So let's talk about some of the use cases. The most obvious one, of course, is local development. This is an alternative to Minikube or to like the Docker desktop Kubernetes that you can install with Docker for Mac or Docker for Windows or whatever. The caveat is, and it's not the same for most of the local clusters, is that you can't utilize load balancer or cluster IPs, and you can't really do much with ingress services. So if you're trying to like test Trafic or something like that, probably not a great idea to use one of these. You'll want to use something a bit more robust, like on a VM or something like that. But I think the power of kind comes in CI. So you can utilize kind in your continuous integration. One thing that we're doing at Conde already is validating our Helm charts. Whenever we update them, we have a kind configuration that deploys Tiller, and then we can validate that the Helm charts work in CI before we ever merge that back into master. Same goes for things like cluster configs. So one example of that is pod affinity and anti-affinity. Also like node affinity, all that kind of stuff. So your selectors, you can test those with kind. And the other one that I've been sort of playing with lately is pre-merge ephemeral environments. So if you have an application, the developer creates a PR, you can spin up temporary environments, deploy the application into that environment, and yeah, you can then test that application with a temporary environment before you merge it. There are a few caveats here. One is that by default, Kind only accepts traffic from the local host, but you can configure that to open it up to accept traffic from elsewhere. So as I said, Kind in CI, it is tested and working. They've actually, the developers have been kind enough to provide CI examples for various different CI providers. So the big ones are there: Circle CI, Travis, GitLab, Concourse, Drone. There's Azure there. I don't like talking about them. No, I'm kidding. I think CodeShip is also there on the list, and I think they're also in the early stages of testing some of the various AWS offerings. So it's a rapidly growing project, and I recommend you check out some of those examples. Being able to spin up an entire cluster in your CI in 30 seconds is quite a valuable thing. So if we want to compare it to some of the alternatives, as I mentioned, Minikube and Docker Desktop, Minikube either requires a hypervisor to be running, such as a VirtualBox, or it will use the local Docker Desktop installation, but it will spin up a container for every component within the control plane. You're also fairly limited in your sort of multi-master clusters. It's not CI friendly, and it's much slower to start up. Just casual dyslexia there. If you've used Minikube, you'll know that it takes a good probably 5 to 10 minutes sometimes to start up a cluster running within like a VirtualBox VM. So it's not entirely quick. The Docker Desktop, it's a bit quicker to start up, but it's very slow to install. There's no HA support, so you can't test some of those HA configurations. Again, it's not CI friendly, and it's much more resource intensive. The Kind doesn't use a considerable amount of your local machine resources. There's probably some wizardry going on in the background there, but I found the Docker Desktop Kubernetes to be much worse on resources and kills your laptop battery if you're ever on a laptop and stuff like that as well. Some additional features that I'm not going to go into depth today is mounting your host machine's file system. You can mount paths via that configuration file that I mentioned before. You can customize some of the networking stuff. Kind ships with its own very lightweight CNI, but if you want to rip that out and put something in like Weave, you're more than welcome to do that. And as I said, you'll also have options to customize, say, the listen address. That's the address that will allow traffic from outside of your local machine to enter into the cluster. For security reasons, by default, only localhost traffic is accepted. And you can configure like the API ports and stuff like that for the Kube API. So thanks for listening. And if you have any questions, please let me know.
Do you have any questions? I'll see if I can find another microphone.
If you just shout it out, I'll repeat it on the mic. So right, okay. I wasn't aware of that. So the gentleman basically said that as of 04, Weave now comes baked into Kind. I wasn't aware of that, so it's good to know. Yeah, it's a good question. I'm not 100% sure on that. Any other questions? Sorry.
What use cases have you seen? Mostly CI stuff.
Yeah. Yeah, so the question was, what use cases have I seen? As I said, most of the use cases that I've found to be most useful are in CI. The limitation of like node ports and ingress is unfortunate. I'm not sure they have a whole lot of plans to change that in the future, mainly because a lot of the use case that sort of was the reason that kind exists is for things like Kubernetes conformance tests and for testing operators and things like that. So things that are very easy to test within a CI platform rather than needing to expose those ports. If you're not too worried about needing things like load balancer on your services and things like that, then yeah, look, for local development, you're still going to be using less resources and it's going to be faster to spin up clusters. You can have HA clusters and multiple clusters running at one time. So it is.
Any other questions?
Yeah, so it is. So the question was, is it using the say Docker desktop daemon, or is it come with its own? It does use the local. The only dependency of kind is that you have to have Docker desktop installed. So it uses the local Docker daemon. Fantastic timing. But that's really the only dependency you have. And that's why it works in those CI environments, because most of those CI environments already utilize things like Docker machine underneath for spinning up remote Docker containers. So it's pretty easy to use. Yes, but I imagine most of us already have that installed.
Deployment within the client, which uses a Docker container first, and within that, I'm trying to mount the Docker socket host path volume within the Docker container, so that I can have my Docker daemon run even inside the container. So this is like a 3-layer of abstraction. Docker. Exactly.
Docker section.
It's like Docker on Docker on Docker host.
But why? I can't answer that question because I can't think of a use case.
Let's think about a situation where
People at home want to hear it too.
all right, fine. All right, so the use case that I'm talking about is that when you have a CI/CD pipeline and you want to use a base image, that base image may have vulnerabilities already inbuilt within that. And if you want to scan for vulnerabilities within a CI/CD pipeline or an executor, what happens is that most of the software that you have today, doesn't matter whether it's OSS or enterprise software, they are going to spin up another container to scan for that vulnerability within that base image. Now, to spin up another container, you need to have Docker daemon running within the container, plus it should have access to the Docker host socket. And that's a use case, because this is a valid use case. I mean, I'm talking to many customers. I'm not talking about the kind, but I'm just trying to think that already kind has a 1 layer of abstraction. Can we put another 2 layer of abstraction to... No, I'm not talking about rootless. Rootless is a totally different one. No. Sorry.
So I understand what you're saying in that use case. my first thought is that there's probably better ways to do it than to utilize something like kind.
It runs on, let's say, our Kubernetes engine or AWS or Azure or GKE for that matter. And it's pretty amazing the way the customers are using those platforms because those are built for those enterprise workloads, which is all fine. But I'm just trying to think, can we contrast that solution within kind or not?
So yeah, I guess I can't answer that question for sure because it's not something that I've attempted to do personally. You, as I said, you can mount. It is just a Kubernetes cluster, really, right? So I guess the extension of that is you should be able to do whatever you can do effectively with Kubernetes. To the cluster, the node that it's running on looks like any other machine. So yeah, so it looks like just any other normal host. So I don't conceptually, I don't see how there would be any restrictions on that, but I can't be sure.
Last question?
But basically, in regards to his question, I don't know if this will work, but what he asked made me think about the networking features within that particular within kindness, and then that made me wonder whether or not if the software that you're using, you could maybe mount the HTTP port for the Docker service wherever it may be located, based on how the networking configuration works for kindness. Is it? Do you use the host? How's the networking set up? Is it like a virtual interface or what's the?
Right, I think this is the decent conversation.
Yeah.
about feedback.
So yeah, we'll wrap it up there. Thanks everyone for listening.
Nice. Sorry. Thank you, Josh. Sorry to cut it short, but like the pizza's now sitting there waiting. Let's just like eat, and then if you want to talk about the configurations and stuff, we can do that over pizza. We'll have a snack and then come back in 15-ish. Cool. Do, 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 do. 3-minute warning. Can everybody get their slices in? Ladies and gentlemen, grab a slice, grab a drink. Du-du-du-du-du. You know, it's always like, I always like a structure to my evenings. And normally it's always the same structure, get in at a certain time, have 2 speakers, and then have the little break and another speaker. But because of the pizza mishap, we're just gonna have 2 talks in a row now. So we'll have a break now. So make sure everybody's, you know, got drink, make sure there's food and stuff like that. Is the foosball winning? Surely you can do a rematch afterwards. Cool. I think we're gonna just go get going. I would like to welcome Anna from Paybase to the stage. Give her a round of applause. She's finally here.
Okay, can you hear me all right? Great. Thank you and welcome to Docker London. I'm sorry I'm late, but it happens. Okay, so let's go to it. Have you ever heard of fear of missing out? A while back, when I started working with Kubernetes and containers, it was very easy. We were talking about Docker and nothing else. And you didn't have to worry about anything because it was just working. It was great. And then a few years ago, a year and a half ago, I started hearing all of these new concepts like CRI, the Container Runtime Interface, OCI, the Open Container Initiative, and things like container runtime, stuff like that. And the reality is that a terrible fear of missing out overcame me. I felt like if I didn't know all of these new terms, I will be left behind somehow. But I didn't have any time to think about any of this because I was busy with more important things. And in November last year, I got an email from Google Cloud telling me that now you can migrate your GKE nodes from running on Docker engine runtime to containerd runtime. And I thought, what better way to actually find out about all of these things I've been wondering, if not to try to migrate my own workloads into containerd nodes. And this brings me to today and what I'm going to share with you about stuff like user performance, how containerd compares to Docker engine and other container runtimes. What is a container runtime? In case you don't know, I personally didn't know, although I've been using container runtimes for a while. So yeah, that's what we're going to talk about. To tell you who I am, so my name is Anna Kalin. I'm a systems engineer at Paybase. And Paybase is a payment services provider that's API first. And we're currently providing the most flexible solution to payments that also takes care of risk and compliance. And of course, you can find me on Twitter and LinkedIn and so on. So we're going to cover what the container runtime is. Then we're going to talk about the different types of container runtimes because there's multiple. And then we'll have a quick comparison between Docker, containerd, and CRI-O, and an architecture overview of containerd as well as Docker, a migration overview and all of the steps that you would need if you're curious, if you want to try it yourself, and some user observation, and then we'll wrap everything up. Okay, so what is a container runtime? So according to a definition that I have found online, a container runtime is responsible for all of the parts of running a container that isn't actually running the program itself. So personally, when I read this definition, I didn't actually understand much because it doesn't tell you much. And probably one of the reasons why I didn't understand much was because I was actually thinking of containers a bit like this, like how a VM sits on top of the kernel, the hypervisor, and then the VM. And in my head, that's how a container was working. But in reality, that's not how a container works. A container is just an isolated process on the kernel. So really, the way that diagram will look like would be more like this. So you have some sort of client that talks to a container runtimes, and that runtime gives commands to the kernel to create these isolated processes that we like to call containers. Now, there are things, a few features of the Linux kernel that give us these containers. So they give us the process isolation in order to create containers. So here we're talking about namespaces, which, so not Kubernetes namespaces, so Linux kernel namespaces, which partition the kernel resources. And we have three types of namespaces. We're talking about PID namespaces, which take care of the process ID numbering so that it allows different containers to different processes to have the same process ID in different namespaces. Then we have the net or networking namespace that makes sure that ports used by a container don't meddle with the ports that are actually being actively used by the kernel. And we have the mount namespace, which takes care of mounting and unmounting the file system, the kernel file system on a container. Then we have C groups or control groups, which take care of resources, so CPU limits and memory limits. And then we have this thing called seccomp PPF, which is a security feature that tells a process what system calls that process is allowed to do. So if you think of it as a filter of what the process is allowed to do. So these are the features that allows us this process isolation. And the way I like to think of containers after everything I've learned is more like this image of a kiwi in which the middle, the core bit, is the kernel. And then all of these little slices are the different namespaces, and within them you have those processes and their functionality and how they interact with each other. So let's look at the different types of container runtimes. When we talk about container runtimes, we talk about low-level container runtimes and high-level container runtimes. And the difference between them is, well, basically everything I've told you until now about what the container is and the process isolation and all of that. So those processes are built by low-level runtimes. And examples of those are LXC, runC, and LMCTFY. And but just having those processes on the kernel is not enough to use containers properly. You also need additional APIs, additional functionality. You need the things like packaging images and building images and so on. So those functionalities would be taken care by high-level runtime. So this is where something like CRY-IO or Containerd comes into place. And Docker Engine, it'll become more clear in a second, but Docker Engine is an end-to-end solution for low level to high level. So it contains all of the functionality in one. So based on everything we've been talking about so far, the way I would define container runtimes is a container runtime is responsible for setting up namespaces, C groups, and then running commands inside those namespaces. Do you all agree? Yeah, cool, thank you. Okay, so this is a good time to introduce a bit more terminology. So we've spoken about CRI, so the Container Runtime Interface, which is just a plugin interface that allows the kubelet to use a wide variety of container runtimes without needing to recompile. Then we have the Open Container Initiative, which is a Linux Foundation project that designs open standards for operating system level virtualization. So that's specifically for containers. And then we have CRI-O, which is an actual container runtime, and we'll get back to that in a second. Okay, so in terms of comparison between Docker Containerd and CRI-O, let's start by looking at the Docker architecture. So it has quite a few a lot of features, but you can see here that one of those features are Containerd. So Docker Engine allows you to build, push and pull images. It gives you networking functionality. It gives you persistent storage functionality. But in reality, in a Kubernetes cluster, okay, we'll do it this way. In a Kubernetes cluster, you don't need all of that functionality. You don't need the networking bit because Kubernetes itself has those features already. You don't need the persistent storage because, so for something like GKE, you'd probably be using one of the Google Cloud storage. So really what you really need in a Kubernetes cluster to run containers is this bit here. So the high level container runtime and the low level container runtime, and then a few other features. Now, a while back, Docker split its functionality into different projects. And so now we have Docker Daemon, we have Docker Containerd, and we have Docker Run C. And Docker Containerd and Docker Run C are vanilla versions of Containerd and Run C. But that's when you're installing Docker, these are all of the features that you're getting. Done this? So looking at Docker versus Containerd and all of the different features that they have. So for Docker, you'd have the kubelet, then you have the CRI interface, then you have the Docker shim that plugs the CRI interface with the actual Docker daemon. And then you have Containerd, and then here you'll have low-level runtimes and the containers. And for Containerd version 1, you still have the kubelet, you have the CRI integration, the CRI Containerd feature, and then which is the implementation of CRI for Containerd. Then you have Containerd and again the low-level container runtime. Now I have also added the Containerd version 1.1 because they're slightly different. So in 1.1, the CRI Containerd component became a plugin, and that allows for much better performance and lower latency. So if we are to look at the limitations between Containerd and Docker Engine, just by looking at this particular image, you might say, well, wait a second. I'm getting very few features from Containerd compared to Docker Engine. Surely I'm missing out. Again, you are not missing out if you're running in a Kubernetes cluster. If that's all you need, you're not missing out. If, however, you're running like, I haven't got the whole conversation earlier, but if you're running like CI/CD pipelines and you're trying to test stuff and you might still need Docker Engine, but you're probably not doing that in your main cluster anyhow. So for production clusters and your main clusters, Containerd will suffice. So it gives you the run image into a container functionality and the push and pull image to a registry. you can commit images, containers to new images via the API, and you can save or load images through the OCI format. And I said that I was gonna touch on CRI-O, which is a very lightweight container runtime, a CRI runtime made specifically as a Kubernetes high-level runtime. And what it does is it supports the management of OCI-compatible images. It supports runC and clear containers as low-level runtimes. And in theory, it also supports OCI-compatible low-level runtimes. And the reason why I say in theory is because in order for CRI-O to support other OCI-compatible low-level runtimes, it still relies on some of the runC functionality. So we've seen how they compare. Now let's have a more in-depth look at Containerd and its own architecture. So at the top, you have all of the different clients that can be used with Containerd. So you have the kubelet, different implementation like Pouch, Garden, Docker. Then you have the Containerd client, which takes care of snapshotting and pushing and pulling images and stuff like that. And then you have the Containerd API, so the gRPC API, in case you want to speak, your application wants to directly speak to Containerd. You have the container shim, Containerd shim, which allows you to plug in and out whatever low-level runtime you want to use. So whether you want to use runC or Kata or other container runtimes. And then you have the metrics API that gives you stats such as CPU usage, memory usage, and so on. So let's have a look at how hard it is to migrate. In terms of the different providers for Kubernetes managed services, AWS EKS doesn't currently support Containerd as a runtime. Azure AKS uses Moby, which is a flavor of Docker, as a container runtime, but customers can deploy their own Kubernetes cluster with a different runtime. And well, GKE is already available. Give me a second. In terms of how you'd go about migrating for an already existing cluster, the first thing you'd do is create a node pool into your cluster using Containerd container runtime. Then you would cordon all the old node pools so that new workloads don't get scheduled on them using this command, which will be available to you if you want to try it. And then you would drain the pods on the cordon nodes by running a very similar command, another command. And that will mean that all of your old workloads will be redeployed into the new node pools. And then you can just delete those node pools. So it's not, it's quite straightforward. As a systems engineer that has many responsibilities, I wanted to add all of the different user observations I have been seen by using Containerd. And I tried to frame them in such a way as they apply to the things that I care in my day-to-day role. So in terms of troubleshooting, as a site reliability engineer that has a lot of SLAs on my mind, I do care about being able to troubleshoot fast and recover from failure very fast. And with Containerd, I have the CRI-CTL, which is a client that allows me to troubleshoot containers and pods directly in my nodes in an emergency situation. And then there's the CTR, client which creates and manages containers directly with the containerd and installs plugins and stuff like that if you don't have access to the Kubernetes API or you're just running something directly on the node. From a performance point of view, well, I have to deploy new features out every day, ideally yesterday. So I do care a lot about performance. So doing a comparison between Docker version 18.03 and containerd 1.1, so containerd is 20 seconds on average faster of pod startup latency, pod startup than Docker. And because I was playing around with this, I wanted to do my own tests. And what I did was deploy the nginx ingress chart from the Helm charts that are stable into a cluster running on, well, first of all, this one is running on Docker version 17.03.2. With the version 1.11 on Kubernetes. And you can see that you can see the container runtime, and you can see at what time the pod was initialized, and then at what time the pod became healthy. And there are about 20 seconds between the two. On containerd, again, doing the same thing, installing the same chart, the same environment variables and everything, you can see that how long it took between the moment a pod was initialized to the moment the pod was marked as healthy is 2 seconds. So that's 18 seconds faster. Also, as an infrastructure engineer with resource optimization on my mind, I care about resource utilization. As you can see from this image, containerd performs better on both CPU usage and memory usage. And I also have security on my mind a lot of the time, especially since we are PCI DSS compliant, and that's a big headache. And if you don't know about it, I'm very glad for you. So containerd has a smaller attack surface than Docker, because in a cluster running containerd, you'd have less features available. And to give you an example, as an attacker, if I got into the nodes that are running Kubernetes with Docker, I can directly start creating images on that using Docker. And I wouldn't be able to do that with containerd because it's the Docker daemon that is creating images and building them. Another reason why I have more security in containerd is because I can actually go on GitHub and see their full security audit from the moment they graduated as a project on CNCF. Yeah, those are the security. So, to sum it up, I personally think that Docker scope is too large for a Kubernetes cluster. Containerd supports multiple low-level runtimes via the runtime handler or the containerd shim if you want to plug in and out different functionalities. And containerd runs on top of low-level runtimes such as runc, kata containers, and others. And obviously, Docker also runs on top of containerd. And my observation is that containerd performs better and is a lot more secure than Docker. I have added some resources if you want to check them out. Thank you very much, and please ask me questions.
Who has questions?
Thank you for the talk. A very brief question. Since you're not using containerd to do the build of your images, what are you using to build the images that you served on these clusters?
So I actually forgot to mention that, so thanks. You normally, I personally normally build images locally. So I still have the Docker daemon locally for building them. And just because Containerd doesn't have the functionality of building images, that doesn't mean that it won't recognize the images that were built by Docker. So for me, it's locally. Yeah.
How do you support, how do you think about
Wait.
how about the support of the entire ecosystem that runs around Docker, which is huge than Containerd? So the adoption of Docker has the growth of Docker has been enormous in terms of the line, and the ecosystem around that has been grown phenomenally than Containerd. So of course I understand that Containerd has their own own set of goodnesses that comes with the performance, security, all that. That's great. But in terms of the ecosystem support, Containerd is much at a much I would say behind in terms of the catching up, in terms of the having ecosystem support. How do you counter that when you go in front of the customer who would say that, you know what, I need a Docker, but then you love Containerd because Containerd comes with this, and then you have to deliver that. So how do you contrast that? Do you always go to the customer and say that go for the Containerd or Docker, or what's the way that you do?
Thank you. So luckily for me, I am no longer a consultant, so I don't have to listen to customers anymore. So I just make my own decisions. But that's not the answer, obviously. Containerd is part of Docker. So Containerd provides certain functionality that Docker needs. I have looked at clusters created with GKE, those ones that I have showed you with Docker versions 1.17. And you can see the Containerd version that they're using. And that version is not as new as what you would get with just running it on Containerd. So on so on a cluster that's running Containerd nodes, you get version 1.1. And on a Docker engine, you get Containerd version 0 point something. And that means that whatever problems there were between 0 point something and 1.1, they would have by now been resolved. So from an adoption point of view, again, if you're running on Kubernetes clusters, I don't see how you'd have any issues with that. Does that answer your question? So just to clarify, would you need that functionality within the Kubernetes clusters that are run? Okay, then you're right. Then you probably will need that same functionality. Yeah.
Rather than have just about the container. So that's what I'm afraid that if Containerd as a Containerd is not growing that fast, or they're not catching up to say that, okay, I'm going to support creating the image locally within the host itself.
Well, Containerd is part of Docker as well. So whatever functionality it provides, the growth will be in parallel. So Docker will just choose whatever version they want to use from Containerd. But obviously, if you need all of the other features of Docker, then you're probably right. You'd still want to stick with Docker.
I just want to say thanks for the talk, because that was really interesting for me. There was a lot of stuff there that I had no idea about. So I can see that Containerd brings a lot of advantages in terms of performance and things, but I just personally, I roughly understand how Docker Docker works and I don't really understand how Containerd works. Have you found that the advantages you get in terms of performance and security outweigh the having to train people how to use this stuff? Like, is there like a big amount that needs to be learned to use this?
I guess it depends on what do you need to train people, how you're using it. If you're spinning up clusters and you're using like something like Terraform or whatever you're using, from the point of, let's say for Google Cloud, you'd run a new cluster, create a new cluster, and then you just say, use this runtime from that point of view. So then there's literally no learning curve there. From the point of view of actually using CTR and cry CTL within nodes, the functionality is not huge. So because of that, I don't see it as being a very steep learning curve. But again, I just took it and I played with it, and that's what I came up with. I haven't tried to upskill anyone on it.
Last question, I suppose. We had one last one.
Thank you very much. That was what an impressive piece, actually. I don't know whether any person attended the onboarding with Google today. Now, there's been a whispering campaign about the full-fledged functionality of Docker. Docker being responsible for breaking Kubernetes clusters in production. Now, the Helm future within Kubernetes itself is a training ground for Containerd. It has every functionality and every usage, and actually helps you learn more about Containerd. And I went out today feeling that Docker in production, especially Google is now becoming very selective. They're not saying it openly, but they're now becoming very selective of which versions of Docker one should deploy in their Kubernetes engine. And I think that's where your talks became very interesting, actually. Containerd is lightweight, and Containerd in terms of its workloads offers much more advantages from a workload perspective, and from a security perspective as well, especially the stability of the Kubernetes clusters, okay? Because of the high levels of iteration of Docker, the high levels of iteration of Docker does not guarantee the stability of the Kubernetes cluster, I see. And that was something that was pointed out today. I don't know whether any person went to the onboarding for Google. It was all day in Wembley Stadium. And they pointed that out, that in the future, they'll be more selective about which versions of Docker to commit to production clusters with Kubernetes. Yeah.
Cool. Well, okay, then the last actual question.
Sorry, a really fantastic talk. My question is, was the security aspect something that was bolted on, as in, or was it a kind of thing that was crucial to actually implementation of this? I'm thinking about how the business kind of responded to this sort of thing. Thank you.
I'm running back to
So do you mean our business, or do you mean, yeah. So we have just tested it. We haven't fully migrated it. And it's not because we think there's a problem with this. It's just because right now I'm the only systems engineer in the company, and lack of resource, basically. But that's changing. So we will definitely do that in the next months or so. In terms of the security aspect, it was just something I really want. I came up with it myself. I was like, what are the security features? Is there any security benefit? And based on everything I've read and yeah, all of the research, those were the security benefits that I came up with.
Based on what you've said so far, are you currently running both Containerd and Docker engine on the same cluster? And if so, do you see a future for that, for maybe using the Docker engine for building images as part of a CI pipeline, while using Containerd as for maybe production workloads and stuff like that?
are we running both Docker engine and containerd in production? Well, in order to do the CI/CD and scanning images for vulnerabilities and all of that, we're still using Docker, but that's separate to our actual production cluster and production workloads. That's just a matter of the workflow that builds images, tests them, pushes them, all of that. So that's completely separate from what's running inside. But even on production, we're still using Docker right now because of the previous comments I've made. But once, in the next few months, once I have a bit more time, our production workloads would only run on containerd, unless, I don't know, for some reason that doesn't work out. But it has, I've tested this and it has worked out. Thank you.
Thank you, Anna. Cool. So let's just go straight to the last talk so we can all head to the pub after that and exit this hot room. So I would like to invite Prasenjit on stage to do the last talk. And while we're doing, waiting for the changeover, I always forget this, but I always like doing this. Can we take a little selfie with me? Just, because I like doing selfie. It's also on video now. It's very, very funny. All right. Docker. Video and video. All right. Smile. 3, 2. Just counting down and away. Give the timer on. Yeah. Not really. I mean, like I'll just like fill the time until he's like set up his laptop. And how's everybody doing? Warm, I suppose. Says the Australian man. Feels like home. Let me figure out the camera again because that's things. Cool. All set? Yeah. Something happening. Yeah, as soon as you press present, and everything's fine. All right, give a round of applause to Prasenjit.
Okay, good evening, guys. My name is Prasenjit Sarkar. I am a product manager within Oracle Cloud Infrastructure. And today I'm going to talk about this multi-stage Docker build to create an effective and secure container and a much more smaller image, which is of course a much more smaller attacker surface. And then how you can build a small image and for building that, and then pushing and pulling as well, because that requires a lot of runtime. So who am I? I'm a product manager. What I care about is these are the technology stack that I'm really passionate about. It's Docker, Python, Kubernetes, Istio, Jenkins, and OpenFast. My Twitter is a Stretch Cloud. That's what I tweet at most of the time. All right, so multi-stage build. How many have you already seen or used a multi-stage Docker build file? Almost 40% people. All right, that's good. So of course, multi-stage build equals to layers. And we will copy those layers where it matters the most. And then how efficiently we need to write those multi-stage Docker build is something that I'm going to go through. So Docker images and layers is like you have the container layer, which is RW, and then you have your image layer, which is read only. And then you have your container runtime. So let's say you use the Ubuntu 15.04 or 16.04 or 18.04, and then you have seen those image layers, which are read-only, and then on top of that, you have your read-write layer. So that's how the layer works. Now, why it is so important? You will add more layer. It is going to increase your image size. That's number one. Number two is large image not only takes time to build, but also it takes time to push to your Docker image repository. Doesn't matter whether you use it hub.docker.com or your own secure or private Docker repository. If you build much smaller image, then you will not only reduce the build time, but also you will reduce the time to deploy either in a standalone or in orchestrated environment, which is Kubernetes in this case, what I'm talking about. And small image is, of course, the small attacker surface. That's why we need to build smaller image and effective containers. Docker multi-stage. So what is that? Now, Docker will allow allow multiple from statements. So when has that been introduced? Is 2 years back, I think 2017, somewhere around February, June timeframe. It was merged in a pull request, and then has been pushed into 17.05 release. Since then, we are using multi-stage build. But before than that, we were, rather around the same time, we were using we were using builder pattern to create effective or smaller Docker container than the multi-stage build. But it was a really, really hard process to go through. And that's why we came up, or rather Docker came up with a multi-stage build. So each from statement marks a start of a new build context, which is assessed by the number or a name that that we are going to define. I'm going to show you how to do that. Each new context, which is the from, is like starting a new Docker file. And you then copy what you want from any previous context into the new context, and whichever is the last from statement as the base or as the final base image. So for an example, you take a distribution, which is, let's say, CentOS, and then you install Python on top of that. So when you install Python on top of that in a particular working directory, you just copy that particular directory to the next image layer and leaving all that other crap outside, because you don't need other libraries, you don't need other build times, you don't need other runtimes. You need only the runtimes or the library that you need to run your Python API code or whatever the application that you're built for. So multi-stage builds versus the builder pattern. So this used to be earlier the case, the builder pattern. So multi-stage build, as I said, it is the separate, we are separating the stages in a single Docker file, and you can copy the context from one stage to the other, and the resultant is going to be a much more small final image. The builder pattern is the build, then copy the artifacts over, and then the results is a small image, but it's a more complicated process, as I said. End result is often something like dockerfile.build and dockerfile.final, and then you have a multiple Docker file. But in the stage of Docker multi-stage build, we're going to have just a one single Docker file, and we will use the from statement to copy the context over and over to the next layer. So what is build context? Now, every build context is something what you are sending to the Docker daemon to build that. So for an example, when you are running a run command, and then you are installing something, for example, you're installing the common tools, you're installing, let's say, Python, you're installing some of the security tools or any other library that you want to build out your stuff. When you do that, you're sending out the context to the Docker daemon. When you look at the log, you'll get to see that what you're actually sending it from your local box where you're actually building that Docker image. So when you run Docker build and then -t and then your name of that, when you're tagging that, and then dot to show the Docker file, when you do that, it's going to send a hell lot of stuff to the Docker daemon. And that's the size of your context. So whatever you are sending, you just be mindful about that size is you're sending it to the Docker daemon, and that needs to be processed within your local box, right? So that's basically your build context. The more context that you send to the Docker daemon, the bigger your build context will be and the larger your image size. You need to avoid unnecessary files and directories, such as, for an example, .git. If you are using _py cache, sometimes I use the py cache to send it to Docker daemon as well. Just copy dot to dot or my directory, because I want to run, I want to have my py cache within the container, so that it can pull up from the Python cache and then run my code much faster than building it from the code itself. So, all right, now I get it. Yeah, that's about the multi-stage. Now, when did the Mozilla pull request? Yes, that's a happy day. So look at the time and date. So that was around March 24th, 2017, when they build and push that PR with the build number of 1705. So it's been there for a little more than 2 years now. So that's about the problems that we have talked about. Now, what about the remediation? What should we do to create that image? What should we do to create that Docker file and then send it? And then also be mindful about the security. Now, somebody has talked about rootless Docker. So we need to be mindful about the user context as well. So let's look at that. So we need to start from a lighter base image. What is lighter base image? Lighter base image based on your need. For an example, do you need, so let's look at the base image and the distro, and let's look at the operating system and the distro that you need to be using, and what's the size for that. So be mindful about what is written on your writable layer. Your chain run commands, as each run creates a layer. So we'll be talking about the run command that you need to run within the Docker file. So one run command creates one Docker layer. That's a read-only layer when you build that one. But if you write the one single run command, and then you do an ampersand, and then run another command within a same run command, the entire run command is going to create just one single image layer. So if you're installing, let's say, 10 different stuff, try to do that within a one single run command than running it in a 10 run commands. If you do that, 10 different image layer will add up the space, add up the build time, the push times, and the pull times as well, right? And then prevent the cache miss at build for as long as possible. Now the Docker build. So Docker file, as we know, that is a series of instructions for building an image. And after each Docker build command, you will get a single image layer. And complete the Docker build execution generates a single Docker image. So so it will flatten out the entire stuff and then will create one single image layer at the end of the day. So let's look at the base image, but base image may not be the optimal image that you are trying to use in your use case. So be very mindful about what you're trying to use. So here, I'm showing you an example what I have built for this demo yesterday. So I'm using a flattened, it's not a multi-stage build, it's a flattened Docker file. So I'm using Python latest. That's an image, that's a distro that I'm using. And if I use that to create and run my API, REST API that I have written, then my Docker file size, which is this, is 979 MB. It's enormous. Think about a slow network where you need to push and then pull into your container run orchestration layer, let's say OpenShift or Kubernetes for that matter. It is going to take much longer time to do that. So be very mindful about what you're using as your base image. It may not be the optimal image, but can you choose another image to host and run your application? Of course you can. Let's look at that. So what I have used here is a quick command to show you the size in MB of a base image of two different distro. The number one distro is using Python latest, which is fine. And the size is 875 MB, okay? When you use Python and then the tag is 3.7, which is the latest one, and -slim, if you use a slim distro, then it's going to use 136 MB. Look at that difference. Can you use Slim? Maybe, of course, it depends on your use case, but most of the time, yes, you should be able to. So that's choosing the right image. Now let's looking at the right distro or distribution of the image. So what operating system should you choose? Should you choose Ubuntu or Alpine or Debian or Oracle Linux or CentOS? Look at the size for everything that I have pulled yesterday. So Ubuntu is 64 MB. Alpine is just 5.58 MB. Debian is 114. Oracle Linux is much more, which is 235, and CentOS is 202. So it looks like the Alpine is the best one to start at, right? So we may start choosing Alpine, but Alpine comes with various different complexities as well. So when you try to, let's say install or switch a user context, think about the commands. Not all the commands in different distros will work with an Alpine Linux. So, but wait, do we really need to have the full operating system? It depends on your use case. You may really need to have a full operating system. What are those use cases? For an example, you want to run the full image of security. Or for an example, if you have a compliance matter where your security team has already certified an image saying that this is the distro that we'll be using for auditing purpose. Fair enough. Go for the full image, full operating system. And of course, the developer friendly, because the full operating system will come up with a lot of tools, the libraries, the common tools, the development tools already built in. So developers should not really think about or worry about how do I inject my tools within that? What are the commands? How do I switch the context and do that? Because everything is built in, right? So of course, so these are the use cases where you really need to use probably a full operating system. Can't help it. Problems with the Docker build. So what you actually want is your application running on top of Docker, and that's about it. You really don't want a compiler. You really don't want your test code that you have pushed into the GitHub or probably in your local directory. You really don't want your build or test log or reports. So easily, these three can be chucked out in a multi-stage build, and you just need to care about your application running on top of Docker daemon. That's it, right? So what is Docker multi-stage build is, let's look at the benefits. So it's a single Docker file, unlike the builder pattern where you may end up having 2 or 3 different builder pattern files. It's a one single syntax to learn, which is from, and you create multiple stages for that. And these are the kind of, the base image, the compilers, then linkers, and the testing, and then the final release within a single Docker file. All right, so let's look at my example, what I have done for this demo. So I have taken Python 3.7 Slim as my base image, which I named as Python-base. Now, from that, I started building out my dependencies within that image. So building out the dependencies is nothing but I tried to copy the requirements.txt where I'm installing the Python modules using pip. And then I'm running that with that command, run pip install -r requirements.txt. And that's about it. I just install the dependencies within that. And I have done nothing within that container or that image layer. Now on the next layer, I'm saying from the dependency as a build, then I'm trying to copy my program files, which is app.py, csvinsert.py, titanic.csv, dataimport.py, and then I'm copying the Swagger YAML file as well, because I'm exposing my API as a Swagger interface. And then I'm creating a user so that at the end of the day, I'm going to run that under a user context rather than a root context, because I really hate somebody to access my container from a root context and do something with that. I really want a normal user to run that within a user space rather than a root namespace. So I'm creating a user and a group, and I'm running a Python script all in one single run command. It's just been stacked together so that everything has been just in one single layer. Once I'm done with that, then I'm saying, now I'm going to create my final release image. With the final release, I'm just copying from different layer what the context is going to matter for me. So first is I'm copying my dependencies where I have already installed my Python modules. Then then from the dependencies, I'm copying the root cache where my actual Python modules have been installed in the other dependency layer. And then I'm starting my data import, and I'm exposing this to my 5000 as that's a Python Flask API, and entry point and a command. That's it. And I'm running that under user app that I have built in a 2 previous layer. What is the image size that I have created? Is no, sorry, it's not there. So the image size for this is 120 MB. From 975 MB, I built an image which only matters to me is 120 MB, right? So multiple run, as I said, is equal to multiple layers. So multiple layers means multiple image, I mean, the image size will grow up. So you need to just stack up your run command, which I have done in here. So I'm installing, pip install upgrade, upgrade the pip. I always do that. And then pip install requirements.txt. Then I'm adding the user, the groups, and I'm installing the SQLite because this is a Python API, which is using SQLite database. And then I'm starting my data import. I'm injecting a data and importing a data, and then I'm starting my actual application under the user app, which is the user context. Now, probably you may not be able to run under the user context of app. So you still need to install all of the software using a root namespace. So let's look at that. So user switching equals to more layers, right? So if you run everything under the user root to begin with, you install everything under the user root, and then you expose your application using your own user. That means you are switching the user context. When you switch the user context, every time it's going to create another layer, more size, right? And then the builder flags that you should really know about. You can use the cache from another image to cache from if you really want to do that, because sharing is caring. So if somebody has already created an image where everything is already built up, so you can use that as a cache image. So you can use that. You can use compress to compress the build context, and that's using the gzip. And no cache, you can ignore the cache, and then you can use squash new layers into a single layer, which is going to be flatten enough completely at the end of the day. And yeah, so this is, by the way, this squash, even until yesterday or even till today, it's in experimental mode. The API is API 1.25 plus. It's still in experimental mode. And in my case, the way that I have built my image, it did not do much when I flatten it up totally into one single image. It just saved just 2 MB from 120 to 118. And that's about it. Any questions?
So do we have any actual questions before we are very, cool? Because the aircon switched off like half an hour ago, and I really want to go outside.
Thank you very much. I basically have 2 questions, and that's related to Python. Did I hear you correctly when you said we should remove the Python cache when we're deploying onto Docker to reduce the build size?
I have to go give it back because otherwise it will be on video.
Yes, I said that so there are times where I really need that Py cache inside my Docker container. And there are times which I really don't want. Depend on how fast I know that how it is going to be compiled within the image, and how fast I want my application, in this case a REST API, to just spin up. In my case, I really did not care because it's a demo application. So I don't probably need Py cache to be injected into the container because it requires a more size and of course the build times. So sometimes I do that. Sometimes I don't, depend on what exactly I'm trying to run. Your next question, please.
Deploying Python applications onto the web, not necessarily with Docker, but with one of your products, WebLogic, inside WebLogic domain, we try to slim down the build process by removing the cache and the the functionality of the Python application, ceased basically, and the iteration levels for it to work meant that we had to bring back the cache. Because remember that Python is not a compiled language; it's interpreted and sits on top of the JVM. Does it have the same impact on a Docker container when you remove the cache? Have you noticed any difference?
So the question is, in WebLogic case, when you run that, when you run that on top of JVM, it's basically a Python script, and then Python is looking at the PyCache to spin up that entire process, and it freezes when it is not able to find the PyCache. And in my case, whether I have seen that situation or not, unfortunately, I haven't seen that, because the applications that I have built or the code that I have written really doesn't care about whether I have a PyCache or not. Maybe it's going to be 2 seconds faster, but who cares? It's not a WebLogic anyways. It's not an enterprise grade applications. I'm not an app developer no more. I'm no more app developer right now. But the kind of a demo that I write doesn't really matter whether I have a PyCache or not. It's pretty small, and it just spin up and then do the stuff that I really want to show, the integration in between the ecosystem, and go from there. 235 MB.
One last question, and then I really want to go.
So you mentioned about having multiple runs and how that adds multiple layers, which delays the build process, which I've experienced as well. I'm just wondering if you've experienced with this, because I've seen this done in a better way, in the sense that when you do a run, instead of running all of your commands with and, you can just create a script, yeah. To me, it makes the Docker file cleaner, and it's easier to follow. And when you're doing a run with loads and loads of installation steps, it's like there's an indentation problem sometimes. You need to be really careful of how you do it.
All right, so yes, from a look and feel perspective, yes, it looks much cleaner. But if you are a developer and I'm a developer, I would really love to see what is there in your script, rather than, I mean, of course I can see that because that's there in your folder where you are running your Docker build command. I can look at that file, which is okay. But then when I'm looking at your Docker file, I mean, as a developer, I would really love to see what you're trying to install to give you feedback, whether do you really need that or not? Because in a lot of cases that I have seen, when I push that code out, and if there is a better way to do it, and if I don't need a particular runtimes, I have been given a feedback into my issues, GitHub issues, saying that, you know what, you really don't need that. And I did not know it. So when you build that Docker image, and then when you share that with somebody, and then when you push that code into the GitHub, if you have a script, people will not able to know that whether that script, what contains within the script. Absolutely. That's the case. Yes. So she said that you can have that script file within the same repository, within the same tree, and then push it to a repository, whatever you like for, and people will be able to see that. Yes, technically, all you're saying is possible. It's all good, but it's a personal choice that I'm saying is that I really love to see what's written on the Docker file, rather than going multiple here and there to see whether the script looks whether the script there or not. It looks clean, to be really honest, but Absolutely, absolutely. It totally depends on that, how much run you are running within that container layer.
Thank you so much. Well, that concludes our July edition. Thank you to Prasenjit, to Anna, and to Josh. Round of applause. Thank you to Babylon for hosting us. And yes, right. And let's just go to the pub right now. Follow John, we're going to the Hourglass. If anybody wants to take the pizza and disperse it to anyone they might need it most or something, if it's still left, then please take it with you.